ground fault circuit interrupter, or GFCI, is designed to protect against electrical shock by monitoring the current balance between the hot and neutral conductors. It trips when it detects an imbalance, indicating a current leakage to ground. Several factors can contribute to a GFCI tripping and melting, particularly when a motorhome is involved. Firstly, an overloaded circuit is a common cause. Even though the GFCI is rated for 20 amps, the motorhome, through a 30 to 20 amp adapter, might be drawing excessive current. This doesn't necessarily mean exceeding 20 amps continuously, but frequent surges or a sustained draw close to the limit can overheat the GFCI, especially if there are any pre-existing weaknesses in the device or the connections. Secondly, a loose neutral connection at the GFCI or anywhere in the branch circuit can lead to arcing and heat buildup. This is because a loose connection increases resistance, and according to Joule's law, heat is proportional to the square of the current times the resistance, or I squared R. This heat can melt the components of the GFCI, especially the grounded conductor side, as was observed. Thirdly, a faulty GFCI can also be the culprit. The internal components of the GFCI might be defective, causing it to trip prematurely or fail to trip under actual ground fault conditions, leading to overheating. Internal OC protection, if faulty, could cause the GFCI to overheat and melt out. Fourthly, a ground fault within the motorhome itself can cause the GFCI to trip. This happens when current leaks from a hot conductor to ground within the motorhome's electrical system. The GFCI detects this imbalance and trips to protect against electrical shock. Fifthly, harmonic currents generated by the motorhome's appliances can sometimes interfere with the GFCI's operation. Harmonic currents are multiples of the fundamental frequency of the alternating current power supply, which is typically 60 Hz. These currents can distort the waveform and cause the GFCI to misinterpret the current balance, leading to tripping. Sixthly, voltage fluctuations or surges can also damage the GFCI over time, making it more susceptible to tripping or failure. Voltage surges can stress the internal components of the GFCI, weakening them and making them more prone to malfunction. Seventhly, incorrect wiring of the GFCI or the branch circuit can lead to problems. If the hot and neutral wires are reversed, or if the GFCI is not properly grounded, it can cause it to malfunction and potentially overheat. Eighthly, corrosion or contamination of the GFCI's terminals can also contribute to overheating. Corrosion increases resistance, leading to heat buildup, while contamination can create a conductive path, causing current leakage and tripping. Ninthly, the age of the GFCI can also be a factor. Over time, the internal components of the GFCI can degrade, making it more likely to trip or fail. Tenthly, the type of load connected to the GFCI can also affect its performance. Certain types of loads, such as those with high inrush currents or nonlinear characteristics, can cause the GFCI to trip more frequently. When troubleshooting a GFCI that is tripping and has melted, it's important to follow a systematic approach. Firstly, visually inspect the GFCI and the surrounding wiring for any signs of damage, such as discoloration, melting, or corrosion. Secondly, check the tightness of all connections at the GFCI, the receptacle, and the circuit breaker panel. Use a screwdriver to ensure that all screws are properly tightened, but be careful not to over-tighten them, as this can damage the terminals. Thirdly, test the GFCI using a GFCI tester. This device simulates a ground fault and verifies that the GFCI trips properly. If the GFCI does not trip, it is likely defective and needs to be replaced. Fourthly, measure the voltage at the receptacle using a voltmeter. Verify that the voltage is within the normal range, which is typically 120 volts in North America. Fifthly, check the circuit breaker for any signs of damage or overheating. If the breaker is tripping frequently or feels hot to the touch, it may need to be replaced. Sixthly, inspect the wiring in the branch circuit for any signs of damage, such as frayed insulation or exposed conductors. If you find any damaged wiring, it should be repaired or replaced by a qualified electrician. Seventhly, check the grounding system to ensure that it is properly installed and connected. A faulty grounding system can increase the risk of electrical shock and cause the GFCI to trip. Eighthly, if a motorhome is involved, inspect its electrical system for any signs of ground faults or other problems. A qualified electrician can use specialized equipment to test the motorhome's electrical system and identify any potential hazards. Ninthly, consider the load connected to the GFCI. If the load is excessive or has nonlinear characteristics, it may be necessary to reduce the load or use a different type of GFCI. Tenthly, if all else fails, consult a qualified electrician. Electrical work can be dangerous, and it's always best to leave it to the professionals if you are not comfortable working with electricity. An electrician can properly diagnose the problem and make the necessary repairs to ensure your safety. In summary, when dealing with the tripping and melting GFCI, particularly in situations involving a motorhome, it's crucial to consider factors like overload, loose connections, faulty devices, ground faults, harmonic currents, voltage fluctuations, incorrect wiring, corrosion, age, and load type. A systematic troubleshooting approach, including visual inspection, connection checks, GFCI testing, voltage measurement, circuit breaker inspection, wiring inspection, grounding system verification, motorhome electrical system inspection, load consideration, and professional consultation is essential to identify and resolve the issue safely and effectively. If the motorhome was pulling high current, it could cause the device to melt out. The OC protection may be faulty. Therefore, it is recommended to have a qualified electrician inspect the GFCI and the branch circuit. The electrician can check the GFCI for defects and make sure that the branch circuit is properly sized for the motorhome. Also, an electrician can determine if the motorhome is wired to the branch circuit correctly.